Now let's go ahead and work on the inverse. So the main thing to understand about the inverse is like when I'm evaluating a function, I have to say tangent of theta, that is equal to y over x, right? So when I say like tangent inverse of 1, basically what I'm trying to do is I'm trying to find what the angle is, right? So basically what this is saying is tangent of what angle is equal to a 1, right? So when you're trying to understand this, you're saying theta is equal to a tangent inverse of 1. So what angle is going to produce a 1 when I take the tangent of it? Now, it's also important to understand our restrictions because we have restrictions for the inverse tan, inverse cosine, and inverse cosecant. So the tangent is going to be restricted to the first and the fourth quadrant. Cosine is restricted to the first and the second quadrant. And sine is restricted. Sine is going to be restricted between the first and the fourth quadrant as well. So in this case, excuse me, when I have the, okay, so if I want to say the tangent of theta is equal to 1, basically what I'm saying is what angle is going to produce that? Well, this angle here is going to be a pi over 4. And why? Because what's pi over 4 here, guys, is that square root of 2 over 2, comma, square root of 2 over 2, right? And that y over x is equal to 1, which is going to give me my positive 1. I can't use this angle over here because you can see that's not within the restriction, right? I can't use 3 pi over 4. And the reason why is don't both of these angles, when you take y over x, let's go and look at this one, negative square root of 2 over 2, comma, negative square root of 2 over 2. Don't both of these angles, y over x equal 1? Yes. But what's the difference between this one and this one? This one is within my restriction. This one is not. So that's why the answer, the final answer is there's only one answer. And you can always verify this. When you use your calculator, like these are called inverse functions. Okay, so there's only one answer. That's why we have these restrictions, because if we didn't have these restrictions, there'd be infinite many answers. Okay, so we only use these restrictions to be able to get our one answer. And in this case, my final answer here, theta, is going to equal a pi over 4. Now, what about cosine is equal to negative 1/2? When is the x coordinate equal to negative 1/2, right? You can think about cosine represents the x coordinate on the unit circle. So cosine is equal to negative 1/2 over here. Cosine is equal to negative 1/2 here. And if you were to continue this unit circle, it'd be down here, right? But again, do I care about this one? No, right? That's not within the restriction, right? So we don't care about that. Actually, I can even write out there. So then what about this one? What is this coordinate point? Negative 1/2, comma, square root of 3 over 2, right? What angle produces that? The angle that produces that for this angle, theta, is going to equal a what? 2 pi over 3. And voila. What about this example? In this example, we have cosecant negative 1 is equal to a negative square root of 2. Well, remember, guys, cosecant is 1 over y. That means sine is y over 1. So what you can do here is you can just rewrite this as a 1 over a negative square root of 2. Now, this might not seem make any sense to you. But again, if you rationalize the denominator, that's the same thing as a negative square root of 2 over 2. Now, again, when is sine negative? Sine is negative square root of 2 over 2 over here and over here. We don't care about that angle. It's not within the restriction. This is the angle we're looking for. What coordinate point is when sine is equal to negative square root of 2 over 2? Well, that's going to be at a square root, that coordinate point here is square root of 2 over 2, comma, negative square root of 2 over 2. What coordinate point is that? What angle produces that point? And that angle, theta, is equal to a pi over 4.